In this video, we'll explore some of the design principles that we can use to build systems that are secure from the beginning as a design concept. What we want to avoid is ending up in a situation where we design and build a computerized system and then have to come up with security controls after the fact. Adding security once a system has been built is going to be much less effective. It's also going to be much more expensive to do it well. So, in everyone's best interest, designing a system with security in mind from the beginning is the best approach to take. Most likely, one of the best examples today is the internet. The internet was never built to be a secure system. Its design objective was to build a resilient system, and specifically a resilient system for use by the military, which meant that just by the mere fact of being able to connect to the network, you must have been a trustworthy party. Obviously, that's no longer how things were. Everyone can connect to the internet now. There are really no limitations on who is allowed in and who is not allowed in. And that inherent trust that was assumed to be in place is no longer there. And that means that when we look at internet-based security, what we see is measures taken to secure a network that is otherwise insecure. And that's why we see such a patchwork of different steps and approaches that really give us some level of security, but nowhere near the level of security that it could have been had it been designed in from the beginning. When systems are not designed to be secure from the onset, we still can do quite a bit. But what we have to realize is that there will always be compromises. And we see this with many approaches to securing, again, network-based resources, the internet, for example, being one. And this is where, for example, the firewalls come in. A firewall is a device that separates a trusted network from an untrusted network. It's also a device that provides a single point of control and a single point of audit. And traditionally, the way that firewalls have been used is by putting them right in between the trusted internal network and the untrusted internet. The idea then is that the firewall can inspect network traffic going in both directions, from the internet to the internal network and from the internal network back to the internet, and decide which of that traffic it's going to block and which it's going to let through. But that means that once you are past the firewall, so basically you're inside that trusted network, you're inside a trusted network and you can often move around freely without having to encounter many more barriers. Which of course is interesting from an attacker's perspective, because yes, there is a firewall, but as soon as you clear the firewall, the area is wide open for you. So when that became clear, what we added was a concept called an intrusion detection system. It's a device that sits in the network and that's looking for signs of badness. It's looking for traces that should not be there. Often that's based on patterns of known bad behavior. So I'm going to look at the network traffic. Typically it sits on the internal side of the firewall, where it can inspect all network traffic that has made it past that first barrier. And whether you use it as an intrusion detection system, which will just flag alerts, or an intrusion prevention system, which will actually stop traffic, it's still a second tier protection. Which is fine, because we like to do defense in depth, but it does feel kind of clumsy to have to do a lot of this stuff, as point solutions along the way. We're also going to use encryption. And encryption, and we'll talk more about encryption later, but if I use encryption, the consequence is that I can see the network traffic, I just don't know what it means. But it also means that my intrusion detection system all of a sudden becomes a lot less reliable. And while having encryption is good between endpoints, it does limit the usability of network-based defenses because, again, there's nothing for the network to look at other than to pass content. And so as we start seeing, let's have a firewall. Oh, but the firewall doesn't get this. Okay, let's add an IDS. Oh, but the IDS doesn't get this. Oh, let's add encryption. You'll see that we start stacking control upon control upon control because the system was not designed to be defensible from the beginning. And that's often what you'll see. It's a stack of countermeasures, a stack of controls, one after the other, all meant to address certain shortcomings in the design in the first place. Now, that also means that if you are an attacker and you know what these practices are, you can work your way past most of these controls one by one. And while that means that they are effective to an extent, it does not mean that they will be fully effective. And that's one principle that we'll start seeing come back over and over again. There really are no perfectly secure systems. It ties in with the comment I made before, where I said that cybersecurity is a discipline about risk management. And it's risk management because we cannot build perfectly defensible systems. So we have to figure out which parts we feel we're okay with and which parts we're not okay with. Having said that, when we design systems, there are a whole bunch of principles that we should adhere to that make the system defensible from the start. They're listed on the slide. Lots of different terms. What we'll do is run through each of these terms and explain how each of these contributes to building a defensible system. What we'll also be doing offline, when we're not watching the movies, is run through some exercises where we might analyze an existing system and say, okay, can we recognize where these principles have been applied, or maybe can we identify where they have not been applied, and what is the consequence of that? So the first principle is the principle of least privilege. When we talked about law, we said authorization is key. And if I have the authorization to do something, I have been granted the privilege to do something. Least privilege states that I should only have those privileges I need to get my job done, and nothing more. If I have more privilege than I should have, there is a chance that I can do more things than I should be doing. And if I don't have that strong sense of ethics in place, it leaves a vulnerability in the system which could be exploited by an attacker. The other benefit of having least privilege is that there is a smaller opportunity for me to accidentally or intentionally break something. So not only does least privilege contribute to confidentiality and integrity, it also contributes directly to the availability of my information systems. For example, when I'm developing a web application and I'm going to use a database backend to that web application, what I probably do not want to do is connect to that database with all possible privileges. All possible privileges include the ability to, at will, not only delete data, but delete the database as a whole. And under most circumstances, a normally running web application does not need to be able to drop databases or to create new databases. It needs to be able to access data that's in the database, but it does not need to manipulate the database itself. And so if I don't build that into my system, if I don't design my system in a way that the application connects back to the database with only those permissions it needs to execute the operation it is executing, I have a potential for damage. Down the road, especially next semester in CSC 380, Computer and Network Security, we'll explore some vulnerability categories specifically related to databases. And in this one that I'm referring to, it's called SQL injection or SQL injection. SQL injection, if done correctly, if you can use that term, could potentially let an attacker execute arbitrary commands on the database. And that means that potentially the attacker has the ability to wipe out my entire database and create not only a problem of data integrity, but also a denial of service condition. And both of those we don't want. So designing the system in a way that the web application only has minimal privileges will build a more defensible system. Separation of duty is very closely related to least privilege. Separations of duty are often not a technical control, they're more an administrative control. It's a situation in which I'm going to say, if there is a particular task that needs to be done, and that task by itself is high risk, maybe if it's done incorrectly, I could suffer large financial loss, or maybe I could, end up turning off the power to an entire city block, whatever the deal may be. At that point, I'm going to organize my workflow in such a way that one person, by him or herself, cannot complete the task. I need to have at least 2 people to complete the task. That means that I am going to limit the opportunities of a single bad actor to cause damage. Yes, there's still residual risk, because if I have 2 people working together, they could still accomplish that task. But now I'm looking for a situation in which collusion is present. People are working together intentionally to cause damage. And that's not something that we're often seeing. So, for example, if I would allow the same person in an organization to order goods, to receive goods, and to pay for those goods, I'm creating a potential problem where someone can order products, claim they were never received, but they have been paid for. And as a result, I have a fraud capability or a theft capability. Instead, I'm going to say, if you want to buy something, the person who orders the product cannot also be the person who receives the products when they come in. And that's to limit the ability for people to make things go away. That's called a separation of duty, or a separation of concerns. It's a very common way of doing things. More traditional approach would be, looking back at a wartime scenario, is if you're going to be launching nuclear missiles, the impact of an accidentally launched nuclear missile is pretty large. So you want to avoid that as much as you can. And back then, what they often did was create a situation where 2 physical keys were required to launch the missile. Those keys would have to be inserted into the key slots. They would have to be turned at the same time for a system to be able to get armed. The key was that those key slots were far enough away from each other that one person would not be able to do 2 keys at once, no matter how wide their wingspan was. The keys were also carried by 2 different persons, which means that they needed to agree that the missile was indeed appropriately launched. Separation of duty was a way to ensure that we did not have accidental launches. Isolation is another important principle, and it means that we should separate critical resources as much as possible, or maybe what we could say is that we put some form of a boundary between critical resources that is controlled and that we cannot just completely move from one to the other. The benefit is that if I have access to one system and for whatever reason I was able to leverage that access to do unauthorized things, now that's great. That one system that I just was able to influence is indeed influenced, so I don't stop that. But what I do stop is now also all the systems around it from being affected by that same attacker. And that means that, take the analogy, like I can't break into a bank's vault by breaking into the building next door. Like that can't be happening at that point. And so I've added some controls there. The ability for accessing resources only through a single channel is called a reference monitor. So the reference monitor is something that provides full mediation. It means that all access to a resource should be monitored by that reference monitor, and the reference monitor should only allow that access if it's been previously granted. We'll stop here for now. In a second video, we'll talk about a few more principles of secure systems design.